Hi, in this video we're going to take a look at finding what is known as the 5-number summary. So before we get into that, we're going to discuss, take a little detour here and discuss what are known as quartiles. And quartiles are values that are going to divide a data set up into 4 groups, with each group holding about 25% of the data. So here are our quartiles here. We got about 25% between the minimum and the first quartile, also known as the lower quartile. About 25% of the data between the first quartile and the median. Same with median and the third quartile, also known as the upper quartile. And then about 25% between the third quartile and the maximum data value. So Q1 is called the first or lower quartile, and Q3 is called the third or upper quartile. So depending on the context, you may hear these as lower and upper versus first and third. And so the 5-number summary are those 5 values that we have: the minimum, the first quartile, the median, the third quartile, and the maximum. So the 5-number summary divide our data into roughly 4 equal groups. So example 3, find the 5-number summary for the following data set. Well, first of all, notice that our data set is arranged in order from least to greatest. So if it's not in order from least to greatest, we're going to have to put it in order from least to greatest. So what makes it easy for that is it makes it real quick to find our minimum, which in this case is 1, and our maximum, which in this case is 44. Now the median we can get by going inward from the left and going inward from the right and just kind of crossing out values as we go. So cross out the 1, cross out the 44, cross out the 2, cross out the 18, cross out the 2, cross out the 15, cross out the 4, cross out the 15, cross out the 5, cross out the 11, and we get 7 is our median. Now our lower quartile is going to be the median of the median value for this minimum and this median. So we can cross out the 1 and the 7, cross out the 2 and the 5. We have 2 middle numbers, a 2 and a 4. So to find the median of these 2 middle numbers, add them up and divide by 2. So 2 plus 4 is 6, and 6 divided by 2 is 3. So we can add that in as our first quartile, first or lower quartile. Then for the third or upper quartile, we're going to do the same thing, but over on the right side. So we'll start with 7 and 44. We'll cross those out. We'll cross out 11 and 18. And then these 2 middle numbers, 15 and 15, well, when we add them and divide by 2, we get 15. So our third quartile is 15. So we have as our 5-number summary a 1, a 3, a 7, a 15, and a 44. And if we take a look at our data, the rest of our data, we have 2 values between the minimum and the first quartile. We have 2 values between the first quartile and the median. We have these 2 values between the median and the third quartile. And then we have these 2 values between the third quartile and the maximum. So it does split it into 4 groups of 2. 2, 2, 2, and 2. So outliers, we've talked about these before, where we set an outlier as an extreme data value in the data set. In other words, a data value that is very, very large or very, very small compared to the rest of the data values. So we've talked about it before, but we haven't really given a concrete way to determine whether or not a data value is an outlier. Because what I might consider to be an extreme data value in a data set, someone else might not. So in order to alleviate that confusion, we have a method to determine whether or not a value is an outlier. And we can use the 5-number summary to detect outliers. And in particular, we want to use what's known as the interquartile range, which can be found by taking our third quartile and subtracting our first quartile from it. So in other words, our upper quartile minus our lower quartile gives us what's known as our interquartile range, which 50% of our data values are going to be between. So that's a pretty big amount. And so we're going to use that interquartile range as well as the lower and upper quartiles to detect outliers. So we have what are known as fences, a lower fence and an upper fence. So a lower fence is our first quartile minus 1.5 times our interquartile range. And our upper fence is our third quartile plus 1.5 times our interquartile range. And what that's going to do is it's going to mean that any value is going to be an outlier if it's less than this lower fence or greater than this upper fence. So we can think of it like fencing in a backyard to keep our pets from wandering around and getting lost. Where this is our lower fence, this is our upper fence. Any data values between these two are considered okay. Any data values outside of these two, outside of this range of values, this interval of values, would be considered an outlier. So now we have a concrete way to determine whether or not we have an outlier. So example 4, we're going to calculate the lower and upper fences of this example and use it to find any outliers, which you may think we have one, but we may not. We'll have to see. So first thing we want to do is we want to calculate what the lower fence and upper fence are going to be. So our lower fence is our first quartile minus 1.5 times our inner quartile range, and our upper fence is our third quartile or upper quartile plus 1.5 times our interquartile range. Well, we already found these values in the previous example. Our lower quartile is 3, and our inner quartile range, Q3 minus Q1, is going to be 15 minus 3, which is 12. So we could type everything in as we see it to get our lower fence, and then type everything in as well for our upper fence. Notice our upper fence is 15 plus 1.5 times that inner quartile range of 12. So this 12 is the 15 minus 3, which is our third quartile minus our first. And so our lower fence is negative 15 and our upper fence is 33. So any data value that's outside of this interval between negative 15 and positive 33 in this data set is considered an outlier. So we do have that 44, which is greater than our upper fence of 33. So in this case, 44 is an outlier of the data set. So, but we got to make sure we check that, because we might have thought a 32 could have been something that may have been outside, but in terms of our inner quartile range and lower and upper fences, that would not have been the case. So, but this gives us a nice, concrete, surefire way to determine if a data value is an outlier in a data set. All right, so that about does it for this video. Thanks for watching. I'll see you next time.